Alright, today we're going to talk all about the exponent properties. So let's get started with, do you remember all the parts of an exponent? For example, do you know what the base is in this example over here? And the base is the big number. So let's label that real quick. This 2 right here, that's the big number, that is the base. That's the number that's getting multiplied. Now the exponent, that's the little number. So this little number here is your exponent, and it tells you how many times you're going to multiply that to. And that is called our expanded form. So 2 to the 4th, or 2 to the exponent of 4, or 2 to the power of 4. The expanded form of that is telling you that's 2 times 2 times 2 times 2, 4 times. Now our simplified form, that's when you put this all together and say, hey, I have 1, 2, 3, 4 2's, so 2 to the 4th. Now 0 exponents, if I had something like 2 to the 0, it equals 1. Anything to the 0 exponent equals 1. So let's write that. Anything to an exponent of 0 equals 1. Alright, now that you know all the basics, we can get started with our rules and properties of exponents. So the first one's called the product rule. And product means to multiply, and that's what's happening to your bases here. Your bases are being multiplied, but what happens to your exponents is they add together. Let's see why this works. If I have n to the 3rd right here, I can write that as n times n times n. Remember, that's called our expanded form. I'm going to bring down this multiplication in between, and now I'm going to write what n squared means. N times n. So if I go and write that in its simplified form now, I have 1, 2, 3, 4, 5 of them. So the best way to write this is n to the 5th. So instead of sitting there and always writing out how many n's I have, counting them up, and then writing that, we found out that a shortcut would be anytime you have 2 of the same bases multiplying together, you can just add their exponents instead. For example, 1 over here. If I have x squared and x to the 5th, then I know I have x to the 7th. So same basis of x, and then I get to add the 2 and the 5 together. Now over here, I've got my n's, but notice I also have now coefficients. These are just regular old numbers, so this still says 4 times negative 3. In fact, there's multiplication in between every single symbol here. So if I wanted to, I could use my commutative property, meaning I can change the order of multiplication, and I could rewrite this as this instead, if it makes it easier for you to think why I'm skipping through all this. So what I'm really going to say is 4 times negative 3, that's regular old negative 12. And then my exponents here are going to add. Now what am I going to add to this 5? Well, anytime something doesn't have an exponent, it does. It's our little ninja 1, the hidden 1. So 5 and 1 makes 6. So you did not have to rearrange it in your work, though if you want to, you can. All you had to do is put like things together. So my coefficients go together, so 4 times negative 3 is negative 12. I've got 5 n's there, 1 of them there, so I have 6 of them all together. Now this third example is similar to what we've done before. I've just written multiplication a different way. I've used the parentheses around each of these terms, but really we know there's multiplication in between. So regular old numbers, 3 times 5, that's 15. I have 1x here, 2 of them there, so I have 3 of them. I have 1y here, 1 of them here, so altogether I have 2 of them. All right. Second property, the power rule. So power has to do with when you put an exponent on another exponent. So if I have n squared to the 3rd, then I really have n to the 6th. So the simple rule is multiply the exponents, but here's why it's working. If I have n squared to the 3rd, that means I have 3 n squareds. But wait, this is really just the product rule again, because that means I have 2 of them here, bring down my multiplication, 2 of them here, bring down my multiplication, and 2 of them here. So rather than saying I have 1, 2, 3, 4, 5, 6 of them after doing all that work and writing it all out, shortcut method is when I have an exponent to another exponent, all I have to do is multiply them to get the right answer. So let's try it out. First one here, x to the 5th squared. So I'm going to just multiply those 2 exponents together and say x to the 10th. Alright, next one. I've got 5x to the 5th squared. Now, I get to give this squared throughout everything here. It almost looks like distribution. What I'm really doing is just making sure everything is squared. So I'm going to say 5 squared, and then an exponent to an exponent multiplies. So where I don't want you to go wrong on this is 5 squared is 25, not 10. This is still following its normal rules. It's a coefficient, it's a base to an exponent, a big number to a little number. So go ahead and follow your exponent rules for that. But power rule is right here, exponent to exponent. That's where you multiply. Alright, I got another one right here. Now remember, the exponent only goes to the thing in front of it. So this squared only goes to z. There's a 1 on my y and a 1 on my x. So I've got to give out this fifth to everything. So 1 times 5 is x to the 5th. 1 times 5, y to the 5th. 2 times 5, z to the 10th. So make sure that fifth power gets to everything in those parentheses. Alright, last one that I see a lot of mistakes on. In fact, number one mistake all year in algebra will be this and has been this in the past. I've got parentheses and I want everything squared. So when I see this -3, make sure you get those parentheses around your negative because I want all of it squared. Your exponent's really the easy thing here. 3, 2, exponent to exponent, you want to multiply those to 6. But -3 times -3 is +9. Again, where do I see the mistakes? Not usually with the 3's. If I pick a bigger number though, let's say I wanted what's one you might want to search up? How about this? -16 squared. What I find a lot of us do, so we go to our calculator, we say -16 squared. Should be easy, right? Gives us the wrong answer. Make sure if you want all of -16 squared that you write all of -16 squared in parentheses. Your calculator gets tricked. This first one right here is saying, oh, you want 16 times 16, then times a -1. This one says, oh, you want a -16 times -16. So if you're using your calculator, be careful. It can tell you the wrong answer very quickly. All right, those are the first two exponent properties that we're covering today.